Guys, good evening, Rowena and Sanda. I hope you guys are all good there and that you. Oh, this is not what I'm looking for. Oh, it is. I hope you all good, Rowena, Asanda. And hey, Matsaodi. I haven't seen Matsaodi in a minute. I don't know what happened to you. Welcome back, Matsaodi. What happened? Matsaodi, are you there? Okay, let me check this. Because I don't know what is going on, guys. People are, is any one of you encountering problems with the link to log in? Because today it looks like some people are encountering problems. Is there anyone who's encountering similar problems with logging in?
No, sir.
I honestly don't know why. I guess it's their internet connectivity, because if you have weak connectivity, then you can't log in. All right, that's right, 1803, and good evening once more to everyone. And as per promise, yesterday we're supposed to be having this session on Wednesday, which was yesterday. Unfortunately, well, we welcome you back, Matsaodi. Unless if you're using a different name and we didn't know. So yesterday, guys, we had our substation here had a problem. So Eskom technician had to come and attend to it. And that when the electricity was restored, unfortunately, our system, our server remained down until later today at around 2 p.m. It was only then that the technicians were able to fix our connectivity problem. But thanks to them and for their resilience, we are able to host this session. So next week we come back to normal, and next week you're gonna be having mathematics only, guys, because we haven't really had maths for the past 2 weeks now. So we definitely need to have some maths. For next week, we'll leave you guys to have maths. But if time permits, we may have to use Tuesday and Thursday, because I'm looking at the time. You guys are about to start soon with your half-yearly examinations. So we may, if time permits, use Tuesdays and Thursday. Maybe still 1 hour in between Tuesdays and Thursday, just to push some work. But let's get down to the business of the day. I have promised you guys that we're gonna be doing assets and bases today, and true to my word, let us get started. Okay, as its own basis. Right, let's start. So assets and bases, the first thing that we need to know are your two theories, the Arrhenius and the Bronsted-Lowry theories. Those are very important theories. And starting with the Arrhenius theory. Can someone please remind us what is an acid according to the Arrhenius theory? Anyone? Robina is out now. I don't know what happened. I hope it's not load shedding. Anyone, can anyone tell us, remind us, this thing we did in grade 11, so guys, we shouldn't be wasting time here. Definitions. What is an acid according to the Arrhenius theory? Sanda, what is an acid according to the Arrhenius theory? Now, guys, we can't be stopped by definition. Definition is something that you're supposed to be taking out your book and read from your book as it is written. Right, you let me know when you are ready to proceed. I'll just wait for you. I'm going to ask one last time. What is an acid according to the Arrhenius theory? Oh, hi, Unat. Did you finally win to join in?
Hi, sir. Yes, I was able to log in.
I think you need to check your network. If the network is poor, then you won't be able to log in. You must check your network and also try to update your app, your Teams. If it's time to install new updates, you install them. Otherwise, you will be stuck with the old version that will give you problems. So update your Teams regularly whenever there are new updates so that you don't encounter any troubles. Okay.
Okay, sir. Thank you.
So when you finish here, just check if there are any new updates for Teams. If there are any, go to your Play Store and search for Teams. If there are any new updates, install them right away so that you can be able to enjoy. Right, we are stuck here. I'm asking Asanda and Matsawodi, what is an acid according to the Arrhenius theory? And it's silence. I don't know whether they can't speak or what is going on. According to the Arrhenius theory, maybe you can bail us out here. What is an acid according to the Arrhenius theory? This was done in grade 11. No one can tell me they don't know. And I'm not proceeding until you guys tell me.
So, isn't it a substance that releases H ions in a aqueous solution?
It is. Acid releases H plus ion in aqueous solution. And what about the base?
So, the base are substances that release OH ions in an aqueous solution.
Indeed, that is true. The hydroxide ions, you need to know the name of this. This hydrogen ion, which is normally called the proton, and the OH minus, that's a hydroxide ions in an aqueous solution. That is your Arrhenius theory, the gist of your Arrhenius theory. Then there's a second theory. This theory will become handy when we go back to what we call hydrolysis of salts. That is where you are going to apply this mostly. Sometimes they say H plus ions or they say H3O plus ions, one of the two. The H3O plus ions, those are your hydroxyl, a hydronium ion, sorry, this is the hydronium ions. Hydronium ions. H plus ion, that's hydrogen ion, which is also called the proton. And this is the theory of your Arrhenius. He defined any substance that releases H plus ion in water as an acid, and every substance that releases the OH minus ions in water as a base. But this definition was limited. So it is for that reason that these two other scientists, each individually and independently, came up with this observation. And those two scientists were a guy by the name of Lowry and another guy by the name of Bronsted. They each individually and independently came up with this, not that they were working together. No, one person was working elsewhere and another elsewhere. So what did this guy say about the acid and the base? According to this theory, Bronsted-Lowry theory, what is an acid? Anyone, what is an acid according to the Bronsted-Lowry or the Lowry-Bronsted theory? What is an acid?
An
So
acid
substance
is
that
a
gives
proton
up or
donor in
donates
the
ions
presence of
during a
a
chemical
base.
reaction.
Can we have one person, please? I can't hear when you are all talking at once.
An acid is a proton donor in the presence of a base.
Acid is a proton donor. Simply put,
In the
acid is a
presence of a
proton.
base.
Okay, and what is a base?
A proton
Proton
acceptor in the presence
This
of an
one,
acid.
absolutely. A proton is the H plus ion. One donates, the other one acceptor. This theory here is the one that actually leads you to discussing what we call conjugate acid-base pairs. Conjugate acid-base pairs is based on exactly this theory. So we look at this example. For example, you've got your hydrochloric acid solution in water, and then this one is normally a reversible reaction because it's ionic, producing H3O plus ions, which is in an aqueous solution, and the Cl minus ions, which is dissolved in water in an aqueous solution as well. So you can clearly see that between the two, from HCl, I have lost one H, and then now I'm having the Cl minus. The one that has lost the hydrogen is an acid. And then the acid, after losing the electron, will form a conjugate base. The acid, after donating its proton, forms a conjugate base. Hence, we speak of the conjugate acid-base pairs. So this is the conjugate acid-base pair, where HCl is an acid and the Cl minus is its conjugate base. Same thing applies if I'm looking at my H2O. H2O was initially H2O, but after accepting the proton, because it accepts, the number of hydrogen atoms has increased and the total charge has increased by +1. Notice that an acid, the number of hydrogens is reduced by 1 and the total charge is also reduced by 1. So this is my base. With my base, the base will form the conjugate acid. So you've got the conjugate acid-base pairs, H2O and H3O plus ion, those are your conjugate acid-base pairs. HCl and the Cl minus, that is another pair, conjugate acid-base pair. So how do I find this? How do I explain this now? Based on this observation, you say that when acids donate their H plus ions. Oh no, there we go again. This thing. The screen is always doing this. I don't know what is going on, guys. But we have to be delayed just a little bit. Sorry about that. Because I'm out of orientation, so I have to start all over again. Ooh. This thing is wasting our time. Okay, we are back. So we are explaining here based on this theory, on the Bronsted-Lowry theory, we are saying to when the acid donates its H plus ion, what happens? This is what happens. Number of hydrogen atoms is reduced by 1. And the total charge of the acid is also reduced by 1. Oh, these cats are making scary noises. My goodness. Hey, finally. That's so scary, man. Right, so this is what happens. When an acid donates the H plus ion, the number of hydrogen atoms is reduced by 1, and the total charge of the acid is reduced by 1. So it donates the H plus ion to form a conjugate base. The acid forms a conjugate base. Acid donate H plus ion and form a conjugate base. When that happens, number of hydrogen atoms will be reduced by 1, and the total charge is also reduced by 1. Look at that. From HCl, if you start with HCl, you had only 1 hydrogen, but in its conjugate base, you no longer have the hydrogen. It's been donated. The total charge was 0. Now 0 has been reduced by 1 to form a total charge of -1, Cl minus. We normally do not write the 1, but we know it's -1. So the total charge has been reduced from 0 to -1. Number of hydrogens have been reduced from 1 hydrogen to no hydrogen in the conjugate base of this particular acid. Ulalele, please pay attention. Please pay attention to what is going on here. Please pay attention to what is going on. If a question comes to you and says, find the conjugate base of this particular substance, these are the things that we must factor in. But we look at this. Let me finish with the base. Now, when a base accepts, remember base accept the H plus ion from the acid, it will form a conjugate acid. Again, 2 things are happening which are exactly opposite of what happened to an acid. And the first thing is the number of because you are accepting, we expect that the number of hydrogen atoms will increase by 1. Number of hydrogen atoms will increase by 1. And so does the total charge. Look at this. This water, the total charge was 0. Water is neutral. It's 0. But look at its conjugate acid. It has been increased by 1 to form a +1. So it's very important that we pay attention to those little details, because it is those subtle things that lead us to the complete understanding of what we're doing here. The total charge of the base is also increased or increases by 1. This is what happens. Let us make an example. I want to write down the conjugate acid. The conjugate acid of HSO4 minus. Now look at what I want you to do. I want you to write the conjugate acid. What forms a conjugate acid? We said it is a base. A base forms a conjugate acid. How does a base form a conjugate acid? It forms a conjugate acid, one, by accepting the H plus ion from an acid. So when that happens, what do we expect to see? We expect that the number of hydrogen atoms will increase by 1. So that's where we start. So I'm currently having 1. So I want to write the conjugate acid. So your conjugate acid, the number of hydrogen atoms, you only had 1. Now it increases from 1 to 2. What about the total charge? Total charge must also increase by 1. Currently, my total charge is -1. When I add -1 and +1, I get a 0. So we do not write that 0, but we know that when the total charge is not visible, it is 0. Therefore, the conjugate acid, of this substance is that one, H2SO4. Simple and straight to the point. However, had the question been phrased like this, as write the conjugate base now of the same ion. Now, what forms a conjugate base? It begs that question. And then from our understanding, we know that an acid will form the conjugate base. Acid forms a conjugate base. So what are we saying to you about this? We are indirectly telling you that this that is given to you is an acid. And equally so, when they want you to write a conjugate acid, they are indirectly telling you that this species that is given to you is actually a base, and the base will accept a proton. And the total charge will be increased by 1, and the number of hydrogen atoms will be increased by 1. But with the conjugate base, it is an acid that forms a conjugate base. How does that happen? The number of hydrogen atoms, I'm currently having 1, so I'm going to donate this, and I'm left with this. What about the total charge? Total charge is currently -1. -1 minus 1 is -2. So the total charge will be a 2 minus. And that is your answer. SO4 2 minus is the conjugate base of HSO4 minus ion. Questions before we proceed? We are ironing things out here. We are ironing things out. We are speaking contextually. Any questions before we proceed? Proton donor, okay, that I think, sorry about that. Can you please repeat? It's written down, Lucanio. You can read when you are alone at home. Read this statement. Acid donates a proton to form a conjugate base. Number of hydrogen atoms will be reduced by 1, and the charge is reduced by 1. Apply that. Reduce the number of hydrogens by 1 here. You no longer have the hydrogen. Reduce the total charge by 1, we have -2, and that is that. Reduce the number of hydrogens by 1 and reduce the charge by 1. That's it. You reduce the number of hydrogen atoms by 1 and you reduce the total charge by 1. Then you get your conjugate acid, sorry, your conjugate base. That is that. Nothing more to it. You apply this, you read first before you rush into the base part. The base is formed when the statement said conjugate acid. It's the same thing, guys. Read first before you rush into me applying things. First, understand this statement. If you don't understand this, no matter how many times I can repeat this, it won't make sense. It's not about me repeating this 100 times. It's about you reading this until you understand what it says to you. Until that happens, forget about me repeating this. First, listen. Next, read to understand. The first part was write down the conjugate acid of this. When the statement says conjugate acid, indirectly they are telling you because it's only the base, it's only a base that forms a conjugate acid. And that is already written up there to say when a base accepts the H plus ion to form a conjugate acid, only a base can form a conjugate acid. Only a base can form a conjugate acid. They are indirectly telling you that in this statement number 1, HSO4 is a base. What happens? Let's go back. We said number of hydrogen atoms increase by 1. And you go when you do that. How many hydrogens am I starting with? 1. Increase 1 by 1. Now we have 2 hydrogen atoms. Total charge, it's -1. To -1, increase -1 by 1. To increase means to add 1. -1 plus 1 is 0. We don't write a charge of 0. We do not write a charge if it is 0 because we know that's a neutral substance. And that's all. You do the opposite of what you were doing previously. That's all. We'll see more of these questions as we go on to solving problems. You will encounter this more often. You will encounter this very often as we do more questions of similar nature. Okay, don't worry. When we solve problems, you will still find similar questions. We are still going to be addressing this same thing when we solve questions locally. Okay? And Matsawodi, when we solve questions, you are still going to find this and we'll still be enforcing it, emphasizing on that. You will see. Do not worry. Do not be timid. Neither should you worry. You will see. I'll just pop one question out. Let's just pop one question up and let's check. No, this is still equilibrium constant. Look at question 1,1,2. Write it down. Look at this question. Write down the name or formula of the conjugate base of nitric acid. So you are still going to be encountering this. That's why I'm saying do not worry. You'll find this. We'll still be addressing this when we solve problems. Here's another one. Okay, here they only want 2 bases. But there is quite a lot of this question that I've spotted when I was preparing for this. You will still be encountering this very often, don't worry. Here's another one. Write down the formula of the conjugate base of. So you will be encountering such questions. Do not worry. We'll address them when we get to those questions, okay? So we will address those. Right, we proceed now to what we call now. There is a concept of what we call ampholytes. Ampholytes. Again, this was discussed in grade level. An ampholyte, this is a substance that can behave as an acid in one reaction and as a base in another reaction. Anything that can behave like that. And then we're gonna show you with two examples, and then we'll be good. There are not to say these are only two ampholites, but you will be provided with two different equations in which one substance in the first equation behaves as an acid and as a base in the next equation. And to do that, consider the dissociation of sulfuric acid in water. So when sulfuric acid is dissolved in water, because it will do the following. It's an acid, so it's a stronger acid. It will donate one proton. I'm currently starting with 2 hydrogen atoms. Now I'm going to reduce the number of hydrogens by 1. The total charge was 0. Now it is minus. And then it donates that proton. So this is my acid, and this is its conjugate base. Therefore, this is your base. And then the conjugate acid of this base is formed when this water accepts from 2, you add 1. Now you're having 3 hydrogen atoms. Total charge is 0. Add 1, it's plus 1. You have now your what? Your conjugate acid of that base. So your conjugate acid base pairs are these ones and that. Those are your conjugate acid base pairs right there. But then this is not 100% dissociation of sulfuric acid. Sulfuric acid dissociates in 2 steps. This is step number 1 in dissociation of sulfuric acid. In step number 2, this ion that is formed is not completely dissociated, has not completely ionized as yet. So we then go to the second step, wherein this ion, which is HSO4, sorry, this is AQ, and that is also AQ, meaning it's in an aqueous solution, it is dissolved in water. When this ion dissolves in water, now what will happen to it? Again, it is a stronger acid than water, so it donates the H plus ion to water. Now, because I'm starting with only 1, I am no longer having any hydrogens now. The charge that I'm starting with is -1. -1 gives you -2, which we write as 2 minus. This is dissolved in water. It's an aqueous solution. What about your water? Water has done the same thing again. It has accepted the proton. So from 2, I add 1. I'm now having 3 hydrogen atoms. And the charge was initially 0. Now I'm having a plus. And once again, I'm having my acid here, which has formed this conjugate base. So this is my conjugate acid base pair number 1. And again, this is a base which has formed this conjugate acid. When a base dissolves in water, it forms, or rather, yes, it forms a conjugate acid. Base forms a conjugate acid. Acid forms a conjugate base. Hence, we have the terminology conjugate acid base pairs. Now, I want you guys to look at this. I want you to focus on this ion only in the 2 reactions. Notice that HSO4 in the first reaction was the conjugate base of sulfuric acid. Notice that now in reaction number 2, this very same, excuse me, ion is now an acid in this reaction number 2. So in reaction number 1, HSO4 minus is a base, but in reaction number 2, it is an acid. So my conclusion is that this ion is an ampholite. Because in reaction 1, it is a base, but in reaction 2, it is an acid. Questions? Let's take some questions before we proceed. Any questions? Okay, any questions? Going once? Any questions? Going twice? Going thrice? Sold. We are moving forward. And then this is still, by the way, at grade 11 level. This is what we're supposed to have been doing at grade 11. And then we move on to that to look at the what we call strong acids and strong bases. So we have what we call strong acids and strong bases. We are still at grade 11. At this time, we haven't arrived at grade 12, because at grade 12, I think you only do titration and that's it. But we also introduce that to you at grade 12. You only calculate pH at grade 12. That's a only new thing that we add at grade 12, calculation of a pH of a solution or of a mixture. Right, strong acids. Strong acids or bases, these are the acids or bases that ionizes completely or dissociate completely in water. They ionize completely in aqueous solution or in water. Aqueous solution is a water solution. Aquatic plants are plants that grow in water. Aquatic animals, those are animals that live in water. Aquaman, the movie Aquaman, the man that lives in water. So when you see aqueous solution, water solution, because closely related to the term aqua is water. It's a borrowed terminology from, I think, Greece. Is it Greek or Latin? One of the two languages, though, because English is not a language, it's a borrowed language. Most of English terminologies are borrowed from other languages. That is why you find yourself pronouncing this as physics and not physics. Physics, because it's a borrowed term from the Greek. Philosophy, psychology. How can you have a term like this? Psychology, ecology with CH, ecology. That's not English. Definitely not. All right, so it ionizes completely in water, in aqueous solution. When you say water, we mean to say in aqueous solution. It ionizes completely, or it dissolves completely to form the ions. And then this, now you must keep in mind, right? The typical examples of your strong acids and bases are the ones that I'm going to mention here. Anything not mentioned here is a weak acid. For example, all your carboxylic acids are weak acids. Oxalic acid, that is an organic acid as well. It's a weak acid. I'm mentioning this now because in term 3, you're supposed to do a titration experiment of oxalic acid and sodium hydroxide. This strong acid will include your hydrochloric acid, will include your nitric acid, will include your sulfuric acid, will include your phosphorus acid. Is it phosphorus or phosphoric? I think it's phosphoric acid, H3PO4. These are your strong acids that we know. Your strong bases that we know, they include sodium hydroxide, they include potassium hydroxide, they include, I think, lithium hydroxide as well. The rest are your weak bases. So these are your typically used stronger acids. All of these will ionize completely. But look at this. Whilst we are still at this complete ionization, when we speak of complete ionization, it is at this point, ladies and gentlemen, that we look at what we call monoprotic and polyprotic acids. It is at this very point that we look at this monoprotic and polyprotic acids. What is a monoprotic acid? This one is an acid, a monoprotic acid. Don't do that way. A monoprotic acid ionizes to produce 1 mole or 1 H3O plus. They normally have your 1 Cl, I mean your 1 H These two, for example, are monoprotic. They each have one hydrogen. So during their ionization in aqueous solution, they will produce 1 mole of H3O plus. And these two, look at these two, they ionize in more than one step. We have seen that sulfuric acid ionizes in 2 steps. And look at how many H3O plus it has produced. In step number 1, it has produced the H3O plus. In step number 2, it has produced a second H3O plus. Now it has completely dissociated to produce 2 moles of H3O plus ions. If it was H3PO4, there was going to be the third and the last step because it has H3. There are 3 hydrogen atoms in phosphoric acid. So that is about your monoprotic acid. It ionizes to produce 1 mole of that, whereas this polyprotic acid ionizes to produce more than 1 of H3O plus ions. So I hope you guys are still with me here. I'm going to be taking breaks and pauses in between to allow for some questions. Questions so far before we proceed? No questions. Excellent. Let's proceed. So yeah, that is a story about your strong acid and strong bases. And this here, like we have said, these are your polyprotic acids. These are your polyprotic acids. Poly for many, protic from protons. Proton is the H plus ion. Polyprotic acids, monoprotic acids. Pay attention to this, especially when we are going to be calculating the pH of a monoprotic acid and the pH of a polyprotic acid. Please pay attention to that. We're going to be coming back to this when we calculate the pH of a monoprotic and a polyprotic acid. Actually, let us mention it because we've already mentioned. For example, excuse me, hydrochloric acid, when it dissociates, it produces 1 H3O plus. So the concentration of the hydrochloric acid will be approximately the same as the concentration of the H3O plus ions. It's a monoprotic acid. How do we get that? Because 1 mole of H2SO4 produces 1 mole of H3O plus ions. It is from that. So whatever the concentration here is, and I don't know what this is, I can just cross multiply and say, oh, this question mark is also equals to X. Whatever the concentration is, 1:1, X is to X. So that is how I know that this is true. Not H2SO4, sorry, I wanted to write HCl here. What about H2SO4? With H2SO4, 1 mole of H2SO4 will produce 2 moles of H3O plus ions. We have seen that when we're doing that. So if I'm having now, let's make an example with some figures. If this is 0,4, then how can I find that? And then in this case, look at what happens. 1 times that is X. X is equals to what? 2 times that 0,4. You can literally see that, oh, depending on how many protons I've got in that particular acid, and then the concentration of that will be multiplied by 2. So therefore, the concentration of sulfuric acid If I want to find this, I simply need to multiply the concentration because 0,4 is the concentration of sulfuric acid. X is the concentration of the H3O plus ions. Therefore, the concentration of the H3O plus ions will be twice the concentration of sulfuric acid. Amber chemistry. Questions, Uzan? Now, guess Quebec. We proceed. We forge forward. Right. So that's the story about your what we call ampholyte, strong acids, and strong bases. We are summarizing this. We are trying to close the gaps that might have been troubling you. So now you know how we arrived to this. And after this, what do we talk about? I think we are now ready to speak about acid-base reaction. Again, we are still at grade 10 and 11 because acid-base reactions, we actually introduce them as early as grade 7 or 8, if I'm not mistaken. But then we enforce them at grade 10. Then at grade 11, that's where they become fully fledged. At grade 12, we extend it a bit more. Acid-base reactions. Generally speaking, we said to you at grade 8, if not 7, we said to you, when an acid, or maybe let me get my facts straight. No, I have it somewhere. Just need to get the correct one. Okay, let me check for me. Acid, base, and neutral substances. That is grade 7. That was grade 7. Yes, acids and bases, we introduced them in grade 7. And we said to you, when an acid reacts with a base, you will get a salt and water. Generally, that's a generic acid-base equation. That's a generic acid-base equation. Whenever an acid reacts with a base, they are going to form a salt and water which is neutral. So the pH of a mixture, the final pH of a mixture will depend on the pH of a salt because water is neutral. So water, I can't use a neutral thing to gauge the final pH. So we have to be careful about that. Am I missing something? I think so. I think so. Okay, we'll couple it with this one. And then once we're at this one, I want you to remember the pH scale. Again, grade 7, pH scale. We told you about the pH scale that it ranges between 0 and 14. Where 7, which is a halfway mark. Which one is this? Which one is this one now? So, right, from 7 decreasing, when the pH decreases from 7 to 0, you are becoming more acidic. The substance is becoming acidic as the pH value gets closer to 0. And as the pH value increases from 7 to 14, the land or the substance is becoming more alkaline or basic. As the pH increases from 7 to 14, the substance is becoming more alkaline. And obviously the pH of 7 indicates a neutral substance, which is normally your water. Milk as well is neutral. Your acid juice, it's an acid, like your lemon juice. Lemon has got vitamin C. Vitamin C has got ascorbic acid. ascorbic acid. So lemon juice will be acidic. It will have a pH of somewhere less than 7. But that's a weak acid. Ascorbic acid is a very weak acid. Your antacid tablets that you drink when you've got your heartburn, that's why they're called antacid, because they contain an alkaline. The alkaline is the one that neutralizes the acid in your stomach. And when it neutralizes the acid in your stomach, it increases the pH. In your stomach so that it becomes more neutral and you feel better afterwards. That is what you do when you drink the antacid tablet. The acid-base reaction takes place in your stomach. I don't know what should I explain again, Unathi, or I don't know what you wanted me to explain, Unathi, because I've already went past that. Can you clarify what did you want me to explain again, Unathi?
Oh no, sir, it's fine. It was the monoprotic and polytric acid, sir, but it's fine.
Oh. Monoprotic, we said it donates only 1 proton. Polyprotic, it's many. It donates more than 1 proton. That is why it's called poly. Poly means many. Protic from proton. Okay?
Yes, sir.
Monoprotic is an acid that can only donate 1 proton, or that can only produce 1 mole of H3O plus ions. That is mono. Polyprotic, more than 1 mole of H3O plus ions will be produced by such an acid. And that is that. And polyprotic acid, they ionize completely in more than 1 step. More than 1 step of ionization. We've looked at that in the form of this HSO4. When we're looking at this is step 1 of the ionization. Step 2. So any acid that ionizes in more than 1 step is a polyprotic acid. And it produces more than 1 mole. Look at this, of H3O plus. You've got the first H3O plus ion in step 1. You've got the second H3O plus. So this one has produced 2 moles of H3O plus ions. Why is that the case? Because it has got 2 hydrogen atoms. That is why it produces 2 H3O plus ions. Does it make sense?
Yes, sir, I understand.
I hope you do. Right. Acid-base reactions. Before we proceed, any other questions? No more questions. Let's proceed. Right. So this is your pH scale here. And it will become very handy here when you look at your acid-base reaction. Now, we are going to be doing this in conjunction with this that is troubling a lot of people, hydrolysis of salts. And I actually don't understand what is the story. Why can't we understand this very simple concept? Hydrolysis of salt. Hydrolysis means hydro, that has got to do with what? Hydrolysis. When an ion gets surrounded by water. Hydrolysis is a reaction during which an ion gets attracted to water, or attached to water. That is what hydrolysis is. You take an ion into water, but the keyword is in water. That is what hydrolysis reaction is. Hydrolysis of salts. Now we are still going to be looking at your acid-base reaction once more. It's a subtopic under acid-base reactions. We are looking at when a strong acid react with a strong base. Hey, guys, listen very carefully to this one. You are, no, man, please. This thing is literally pissing me off. Literally. I can't write because it's out of orientation. Stop doing this to me. Piss me off. Okay, I'm gonna be a bit slow with this part because now this is one of the new grade 12, something new that we introduced at grade 12. We didn't do this at grade 11. We didn't do this at grade 10, nor at the lower grades. So I'm going to be a bit slow explaining this one so that you understand. And because based on the observations, people are struggling with this concept. I was supposed to be showing you something before we moved to this. I don't know how I forgot, but I want to find diagnostic report. Performance report. Okay, even though, okay, it will still serve the purpose. I was supposed to start by showing you this, so that you understand what is the purpose of having these evening sessions. The purpose of us having this is responding to this, what is suggested in this. I don't know what is going on, but the file just doesn't want to open. Okay, it's fine. Let's check it from here. We're looking for 2022 diagnostic report. Hey, yeah, this is an older one. Why it's giving me an old thing. Okay, let's use that old thing. It's still fine. Let's check. Want to check physical sciences, still economics, geography, life sciences, maths, physical sciences. Good. Let's go a little bit back. Analysis of paper 2, what are they saying? Or maybe let's look at the basic things. This is what informs us when we decide on the topics. As previous years, organic molecules, we don't want that. Lack of knowledge and skills to answer questions involving stoichiometry contributing to poor performance in question 5, 6, 7, and 9. Acids and bases are somewhere around there. I think it's question 9, if I'm not mistaken. So they are saying that the lack of knowledge and skills. Which knowledge and skills here? The theory, but which skills? Mathematical skills, ratios and rates from mathematics. That's a skill you need in stoichiometry. So you need your maths whenever you study physics. Let's go on and check what did they go on to say. And then these are some of the example. Lost valuable tutorial example. Incorrect numbering of questions. I don't know why would you want to do that? Using values incorrectly copied from the question paper. I don't know. People should wear their glasses, their reading glasses. Incorrect copying of formula from the data sheet. Again, wear your glasses, guys. If you know you've got the reading problem, wear your prescribed glasses. Substituting very different from those supplied on a periodic table or constant tables. Wear your glasses. No units provided in final answer. Now, we still have a serious problem with this one. And then acids and bases is question number 7. Look at the average national performance in 2021, 40%. Question 6. No, question 7, sorry. 46%. Below 50%. That is your acids and bases, question 7. 46% of the learners were able, that's an average performance, sorry. An average learner got 46% under acids and bases. That's a call for concern. That's a call for concern. Low state polarity or conductivity, Ka values, concentration from pre-H, stoichiometry calculations. You see, this is what is giving people problem. And a lot of other things that they've said. Let's go straight to what we want to do. Chemical equilibrium. Acids and bases. This is what they said. Some wrote Arrhenius theory instead of the Bronsted-Lowry theory. You just write whatever you want, wherever you want. So people were confusing the two theories. That's a call for concern once again. Failure to write a correct definition. I don't know. An acid is an electron donor. Oh my goodness. How do you address that problem? I don't know. Many candidates incorrectly chose water as an ampholyte. Although water can be an ampholyte, it does not act as an ampholyte in the reaction given. That is why I've deliberately given you an example where water was not an ampholyte. Deliberately so. Incorrect formula. My goodness. Okay. But these are some of the typical things. You guys can always download this. You've got your diagnostic reports. You can just search diagnostic reports and then you say, no, I'm not teaching plan 1 diagnostic report. Yeah, you'll find it. It's there in the internet. You can find and read about some of these things. But because of time, we're going to have to proceed, guys. Whenever a strong acid reacts with a strong base, whenever a strong acid reacts with a strong base, a salt that will be produced there is a neutral salt. Plus water. And then a neutral salt will have a pH of approximately 7. Therefore, this will help you to choose an indicator for titration. Choose an indicator with a pH range close to 7. When you do your titration, you are going to look first, am I titrating a strong acid and a strong base? If the answer is yes, then you must know that the salt produced there will be neutral. And the salt that is neutral has a pH of approximately 7. The pH that I have to choose, the indicator for the titration that I'm going to choose must have a pH range that is close to 7. I hope I'm making sense. The typical example is the most liked titration example in the world. Hydrochloric acid react with sodium hydroxide to produce the salt. Salt is formed when we interchange the N ions. So this OH ion will go to the hydrogen and this Cl ion will go to the sodium. So sodium will form what? Sodium chloride. And H and OH will produce water. That is where your water comes from. So if I look at hydrochloric acid and I look at your sodium hydroxide, this is a strong acid and a strong base. And this is a strong base. This, therefore, will be a neutral salt. So what happens to a neutral salt? No hydrolysis. If hydrolysis was to take place, what was going to happen? I was going to look at this. The first ion is a positive ion by convention. The second ion is a negative ion. I was going to, remember, we said hydrolysis means an ion gets attracted to water. An ion gets attracted to water. So which ions am I looking at? The ions that form the salt. Which are those ions in this case? It is the sodium plus ion in water. There will be no hydrolysis because it comes from the strong acid. The strong acid will completely dissociate. A strong base will also, so it comes from a strong base. A strong base will completely dissociate. So there is no hydrolysis. The same thing with the second ion of this salt, which is your chlorine ion, your chloride ion in water, because it comes from the strong acid. A strong acid completely ionizes in water. Therefore, there is going to be no hydrolysis again. So when the salt is neutral, there is no hydrolysis that is going to take place. Why? Because the sodium and the chloride ions will be floating in water because they are coming from the strong base and the strong acid, whom have completely ionized in water. Questions? Buza. No question. We proceed. The second type will be, I could be reacting. This is scenario number one. Scenario number one is I can react a strong acid and a strong base. Scenario number two, I can react a strong acid and a weak base. And a weak base. With your weak base, because acid has an upper hand, it's a stronger one, the salt that is going to be formed will be an acidic salt and water. So if the salt is acidic, one, hydrolysis yakhona will take place. It will produce, because it's acidic. Remember, an acid is a substance that will produce the H3O plus ion. So we expect that this will be the evidence that when we perform hydrolysis, when this ion is produced, then the conclusion is that it's an acidic salt. Acid, the pH must be less than 7. So you must choose an indicator with the pH that is less than 7 for this titration. Such as what? Look at your strong acid once again. Hydrochloric acid react with ammonium hydroxide. This is a weak base. So what happens? These will exchange. This is a positive ion, that is a negative ion. So the negative ion, this is positive, that is negative. So Lo will pair with the partner of the other one. U will pair with the OH. And you two are going to give me H2O. And the NH4 and the Cl, they are going to pair again with one another. Okay. So what will happen? H and OH will give us water. And then NH4 and Cl will give us ammonium chloride. Ammonium chloride. That is a salt that is formed. So this salt here is made up of two ions, ammonium and the chloride. One is positive, the other is negative. We have already seen that the chloride ion from the strong acid, there is no hydrolysis. So we know that there isn't going to be any hydrolysis of the chloride ion. Why? Because hydrochloric acid has completely ionized in water. But from the ammonium ion, this is where the hydrolysis is going to take place. So this is where your hydrolysis is now taking place. The NH4 plus ion dissolves now in water. Conjugate acid-base pairs. The H plus from the NH4 plus, because NH4 plus, it shows me that this one must have already gained a proton. That is why it has a positive charge. So it will now donate that to produce NH3. And that H plus now goes to water to form H3O plus. As expected, it does produce the H3O plus. Hydrolysis does produce the H3O plus, and therefore the salt is acidic. Amber chemist. Questions? That is how you go about, guys, doing this. You look at the salt formed. In your salt that is formed, which are the two ions that are forming that salt? In our case, the NH4 plus, which is your ammonium salt, and the Cl minus, which is your chloride salt. And by the way, for the chloride ion, it comes from a strong acid. Strong acid ionizes almost completely in water. Therefore, there is no hydrolysis for this one. This ion doesn't get attached to water to form any product. Amber chemistry. Hope you guys are listening. The last scenario, the third and the last scenario, is when a weak acid now reacts with a strong base. Because base is strong, a salt that is going to be formed will be a basic salt and water, which is neutral. So because your pH, your salt is basic, it means that this salt will have a pH of bigger than 7. So whatever indicator that you are going to use, in term number 3, we are going to do the titration of oxalic acid with sodium hydroxide. Oxalic acid is a weak acid. Sodium hydroxide is a strong base. The pH that we use there, which is the phenolphthalein indicator, is informed by the fact that the salt that will be produced there has a pH of greater than 7. Therefore, we need an indicator that will have a pH of bigger than 7. And again here, hydrolysis. A base is a substance that produces, according to the Arrhenius theory, the OH minus ions. So to prove that this salt that will be formed here will be basic salt, we need to show that its hydrolysis produces the OH minus ions. Let us make an example. Let us take acetic acid, vinegar. Vinegar comprises of acetic acid. So we've got your acetic acid, which is ethanoic acid, CH3COOH. We react it with the strong base, sodium hydroxide. So what happens? Of course, we know what will happen. This hydrogen will pair with this OH, and they are going to produce water for us. And then this now sodium here will be attached to this acetate ion, the CH3COO ion. And there is your salt, sodium acetate. Sodium acetate, that is a salt that is produced here, sodium acetate. So let us prove now that this is going to be our basic salt by showing that its hydrolysis is going to produce the OH minus ion. How do we do that? Again, we look at the ions that constitute this. The first ion is a positive ion. The second ion is a negative ion. As you can see, it did not dissociate completely. That's a weak acid. Look at that acetate ion. It still looks so nasty. It hasn't dissociated completely to form oxygen, hydrogen, and carbons. It did not do that. That's a weak acid. So we are going to do our hydrolysis of this salt. First things first, the sodium ion comes from the strong base. Therefore, we have already mentioned that there will be no hydrolysis if this ion is coming from the strong base, because a strong base completely dissociates in water. What about the second ion? Our acetate ion, it is the one that is going to form the hydrolysis. So the H from the hydrogen will be attached to the CH3COO. So one hydrogen gets attached to that. And then you've got now CH3COOH. And water has donated that to form the OH minus ion. Aha! One hydrogen from water. So this is your acid, and this is its conjugate base, by the way, in case you have forgotten. This is the acid, that is its conjugate base. And this is the base, and that is its conjugate acid. So because this hydrolysis is producing the OH minus ion as anticipated, we can conclude without a doubt that this salt is basic, because a base is a substance that releases OH minus in water. Hi, Buzan. Questions? Hamba chemistry. Hamba chemistry. This is what you're supposed to be doing when we say, prove that this salt is basic, or prove that this salt is acidic. You do the hydrolysis. Hydrolysis means what? You take that ion, the constituting ion of that salt, you dissolve them in water, and you prove that they either release the H3O plus, which is acidic, or the OH minus ion, which is alkaline or basic. Hamba chemistry. Hamba chemistry. Hamba chemistry. We are going to get a chance to do at least one question or one example before we depart. But before we get to that, they said this knowledge and skill is lacking of stoichiometry. Stoichiometry calculations. Stoichiometry calculations, the skill that you need here, skills required. Mathematical skills is your skills of ratios and rates. Make sure that you go back to your grade 7, 8, 9 books and you read about ratios and rates. Please do that. It will do you good when you understand what is a ratio, what is a rate, what is the difference between a ratio and a rate. When you speak about percentage, you always speak about rate of increase, interest rate. You speak about all of those things, interest rate. That is a rate. A ratio, we always speak about the ratios in different aspects. When you compare two things, how many boys and how many girls are there in your school? That is a ratio of boys to girls. So we need to have understanding of these things, because and as far as we keep them to be abstract and we do not see their usefulness in everyday life, we won't understand. So we first need to understand what is a rate, what is a ratio, percentage rate, or rather interest rate, interest rate. We always speak about that, repo rate. We were just reading here that the Reserve Bank is going to increase the repo rate by 50 basis points again. What is the meaning of that? What is this rate, let alone the term repo? What is the rate? We need to understand all of those things if we really are to understand and to do maths meaningfully. Understand what you are talking about. And only then will you be able to do it, because how can you do something that you don't even know? You don't even understand. It doesn't make sense. That is why it looks so difficult, because we don't have understanding. That's all it takes. It takes understanding how things work to know how things work. And I don't think that you need to be smart to do that. Step 1 in stoichiometry, you need to have a balanced equation. Because stoichiometry is about interpretation of the balanced equation. Therefore, the first and the foremost thing that you should do is to make sure the equation, the chemical equation that you are dealing with, is correctly balanced. Step number 2, you have to convert the given data. Convert the given data to moles. Now, you could be given one of the three things. One, if you are given the mass, you could be given the mass of a substance. 2, you could be given the concentration of a substance. And 3, you could be given the volume, concentration of a solution, volume of a gas, concentration of a solution, mass of a substance. So when you are given the mass, which formula do I use to convert the mass to the number of moles? You use the formula N is equals to mass divided by the molar mass. And that is that. A relationship between concentration and number of moles, concentration is equals to N over V. A relationship between the volume of a gas and the number of moles is equals to the volume of a gas divided by the molar volume of a gas at a given temperature. These are the three things that you need to do. Then you'll be able to convert, if you are given the concentration, from concentration to the number of moles. If you are given the mass, from mass to the number of moles. If you are given the volume of a gas, from the volume to the number of moles. These are the three possibilities. Not only, but these are the most common possibilities that you're gonna get. Number 3, you must identify the limiting reagent. So this, how do you achieve this? You achieve this by comparing stoichiometric ratio. Stoichiometric ratio is the ratio found in the balanced equation. Stoichiometric ratio from the balanced equation. I hamba chemist. Please listen carefully, guys, because this is what we're gonna be applying from the balance equation to the actual ratio. Where do I get this ratio? This ratio is from calculation or from conversion to moles. By comparing these two ratios, you can easily identify the limiting reagent. And then step number 4, you are then going to use the limiting reagent in your calculations. So my stylus needs to be charged just for 2 seconds. I need to charge my stylus. Been using it since 4 o'clock. Right. So from the conversion, you will get the actual ratio. You are comparing these two ratios, then you'll be able to see. But we'll look at that when we do the calculations. Step number 4, you are then going to use the limiting reagent to calculate whatever is to be calculated. ivale mfana. That's it. These are the basic steps in the stoichiometric calculations. Grade 11, it is where we deal much with stoichiometry at grade 11. Therefore, you need to go back to your grade 11 work thoroughly, attentively, with understanding, and comprehensively. There is just one missing piece of a puzzle here that we're supposed to mention, and that missing piece of a puzzle was pH scale. After the pH scale, we're supposed to tell that to calculate the pH of a solution, we use the formula minus the logarithm of the hydronium, of the concentration of the hydronium ions. And then whilst we're still at that, we're supposed to mention something about, I think it was supposed to be before this, auto-ionization of water. Auto-ionization of water. This will come in very handy. This happens when water ionizes itself to produce. One water is an acid, the other one is a base. It matters not which is which, because these are the same waters to produce this. Because this is neutral and that is neutral, it means that also this is neutral and that is also neutral, because it comes from two neutral substances. Water is neutral, water is neutral. This is only true, listen to me, only true in the auto-ionization of water. Anything that is neutral has got a pH of 7. Anything that is neutral has got a pH of 7. Now, if I know the pH, look at that. We've got what we call Kw, Kc, from the word Kc in chemical equilibrium. Remember, in Kc expression, we exclude pure liquids because the concentrations of pure liquids and pure solids are constants. They do not change. So this Kc, if I were to speak about that, Kc of this reaction will be the concentration of water multiplied by the concentration of the OH, of the H2O plus, and the concentration of the OH minus ions. Aha. So how do I find this concentration here? I can easily find it because I know that pH is equals to minus the log of the concentration of H3O plus. I can always tell what the concentration of that if I know that this is the case. So in my case, you first divide by -1, then we've got -7 is equals to the log of H3O plus. And then you calculate the antilog. On your calculator, you say shift log, that is an antilog of -7. What is an antilog of -7? Your calculator should say 10 to the power of -7. It should say 10 to the power of negative. When you say shift log of -7, and then say equals to, it will say 1 times 10 to the power of -7. So that is the concentration of this. But because the pH of this is the same as the pH of that, it means that also the concentration of that, they are having the same pH. Therefore, the concentration of this and that is the same, such that if I'm looking at the Kw value, I'm looking at this multiplied by that. And then I'm going to have 1 times 10 to the power of 7 multiplied by 1 times 10 to the power of 7. And my answer is going to be 1 times 10 to the power of 14. Because when I multiply the same that by that, it gives me 1 times 10 to the power of -14. Auto-ionization of water. This becomes very important to calculate the pH of a base. this becomes very important. And all the pieces of my puzzle are now complete. That's the theory that you need. Okay, so if you look at if you look at our annual teaching plan, it says, let me check from here, 2023, grade 12, physical science is fine. This is done in term number 2. If you look at this, we have just summarized the work. Acids and bases, 4 hours, a week-long work. So if we had enough time, we needed 4 hours. We just summarized the work that was supposed to be taking us 4 hours. There it is, acids and bases. Here it is, 4 hours. We have just summarized the work that was supposed to take us 4 hours. We've summarized it in 1 hour, 40 minutes. Look at that. The only part that is missing now is for you to speak about your titration. But we'll address the issue of titration when we do the questions, because I'm looking at my time and I want to do just one question with you guys. So look at what they say. Let's check if we have done everything that is needed. Define acids and bases according to the Arrhenius and Bronsted-Lowry theory. We have done. Distinguish between a strong and weak acid. We have done that. Distinguish between concentrated and dilute acid. We haven't done that. We'll speak about it in the form of questions. Identify conjugate acid-base pairs. We have done that. Write neutralization reaction of common laboratory acids and bases. We are still going to perform calculation based on titration reaction and motivate the choice of an indicator. We have spoken about the choice of an indicator, but we are about to do the calculations. So the only two things, titration, we need to speak about titration, and we need to speak about concentrated acid and dilute acids. I don't know if there are any questions from your side, ladies and gentlemen, before we jump into doing the questions. Oh, there's only 3 of you now, Nhlanhla, Unathi, and Asanda. All right, we shall proceed, guys. We only have 20 minutes. I hope we manage to finish just one question. Just one question. Ooh. I'm tempted to just want us to jump straight into this. Question 6, which is before our eyes, because it is what is before our eyes. So, because this is what we have, we shall work with what we have. I'm tempted. I'm really tempted. But I wanted to address the issue. Unfortunately, the person wanted us to do that is no longer here. Let's look at question 3, deliberately, because it speaks about titration, and I want us to address titration in questions. So I'm going to choose this question 3 deliberately, so because I want to address something about titration. Okay. So next time when we meet, we'll try to steal some moment, few minutes, and speak about titration. Maybe perform it virtually. We'll see. Right, guys. Okay. They are saying to you, anhydrous oxalic acid is an example of an acid that can donate 2 protons, not 1. Therefore, this is a polyprotic acid. And thus ionizes in 2 steps. Step 1, look at your step number 1. So in step number 1, you've got this. This is your acid, and therefore this is your base. This acid has formed the conjugate base, and this base has formed the conjugate acid. So these are your pairs. And the remaining are also your pairs. But in the second step, this is your base. This is now an acid, and water is still the base. This is your conjugate acid, and this is your conjugate base. So if you look in this step here, in this reaction, this ion is a base here. This ion is an acid here. Water is a base in both the reactions. So water is not an ampholyte, because water is a base in both your reactions. But this ion here is an acid in step 2, but it is a base in step number 1. This is an ampholyte, not water. Water is a base in both the reactions. I hope you guys are still with me. But let us look at your questions. Write one weight. We've already done that. It's a polyprotic acid. That's a polyprotic acid. Name, so write down the formula of each of the two bases in the reaction. In reaction 2. Reaction 2, water is a base. Conjugate base is the ion, which is COO, with the 2 and the charge of 2 minus. Those are the two bases in step number 2. I hope that is in order. Water is a base, but COO2 ion is a conjugate base. Those are your two bases. And we have already mentioned that this ion here, minus ion, is our ampholyte. And the reason is because this ion is a base in step 1, but an acid in step number 2. That is a reason why. So in some instances, water, excuse me, water can be an ampholyte. In certain instances, just a note here. Water is a base in step 1. Water is still a base in step number 2. Questions? No questions. As we proceed, Nhlanhla. We proceed, Nhlanhla. Give a reason why oxalic acid is a weak acid. Because it's obvious from the definition. It does not ionize completely. That's a reason why. Now we go into your stoichiometry part here. I think I was supposed to divide this into 2. 3,3, a standard solution. Remember, what is a standard solution? You need to know that definition. I will attach the definitions for you, but I would like to believe that your school has provided you with the relevant definitions from the examination guidelines. Remember, you only use definitions from the examination guidelines. Keep that in mind. So you should know what is a standard solution. A standard solution is a solution with the exactly known, not unknown. We know exactly known concentration. That is what. It has a concentration. Look at that. We know exactly what the concentration of that is. Prepared by dissolving a certain amount in water in a 250 cubic centimeter volumetric flask. Calculate the mass that we need in order to prepare that. This is a straightforward thing. I'm given the concentration. I'm given the concentration as 0.2 moles per cubic decimeter. I'm also given the volume, which is in cubic centimeter. Already I see a problem because this is cubic decimeter, but this is per cubic decimeter. So I need to convert this into cubic decimeter by dividing by 1,000, which will now give me 0.25 cubic decimeters. Now everything is aligned. They want me to calculate the mass. I know that when I've got the concentration and the volume, there is a formula which says concentration is N over V. This will allow me to first calculate the number of moles, where this is 0.2 and this is 0.25. Then we multiply both sides by 0.25 to find the number of moles. And this looks like, I think it's 0.05. Am I right? Yes, I am right, I know. 0.05 moles. So these are the number of moles of your oxalic acid. Is it oxalic acid? Yes. Oxalic acid, yes. So these are the number of moles, but the question was not calculate the number of moles. The question was calculate the mass of oxalic acid needed to prepare the standard solution. So I know there is a direct relationship between the number of moles and the mass. And remember what you are looking at, COOH2. So there are 2 carbon atoms here, 0.05. There are 2 carbon atoms, each with a molar mass of 12. I'm having 2 times 2 oxygens, it's 4. I'm multiplying this by the 2 oxygens, I'm multiplying by the 2 outside. So it's 4 times the molar mass of oxygen, which is 16. And I've got 2 hydrogen atoms, 2 times the hydrogen with the molar mass of 1. I hope you guys are following and I'm not leaving anyone behind. 0.05, I don't know what this is. What do we get there? 64 plus 24 plus 2, what do we get?
It's 90, say. 90, say.
90. Thank you.
Yes.
Let's multiply both sides by 90. This becomes, is it 4.5?
4.5, say.
4.5 grams. So that is a mass that we need to dissolve. So in other words, if they ask you to prepare the standard solution, the first thing you do, you go into the laboratory, you take the weighing balance, and then you place something to which, and then you minus the mass of this thing, and then you take your oxalic acid, which is in solid form. You add until you've got 4.5 grams. So you add the pellets here, it will be in pellets form, and then until at 4.5 grams. Then you take this 4.5 grams into a volumetric flask, first into a beaker. You dissolve it in water. Then use a funnel to take this content once it has completely dissolved. And then a volumetric flask will have a mark here. You add water to that very same mark, which is 250 milliliters. Then you have your standard solution. But you must weigh 4.5 grams on the weighing balance. Dissolve that in water, not much water, enough to dissolve it. Add the content to the volumetric flask using the funnel, and then fill it up to the mark. Then you have your standard solution. That's basically how you would prepare this thing in the laboratory. When I say go and prepare a standard solution of this concentration in this much of a volume, this is what you do. You do the calculations, then you go into the laboratory to weigh. Right, 3.4. Now we have to move a bit slow. During a titration, we only use 25 cubic centimeter of a standard solution of oxalic acid prepared in 3.3, which means the concentration is still the same, 0.20 moles per cubic decimeter. Is neutralized. When they say is neutralized by sodium hydroxide, to neutralize means to completely react. Neutralization means to completely react. To completely react means there is no limiting reagent, completely react. according to the ratio, according to the stoichiometric ratio. There is no limiting reagent, there is no excess reagent. It means that the acid is completely used up and the base is completely used up, and you are now having the products. Okay, here is the reaction, the equation there. You will no longer, at the end of titration, this will be completely used up. You'll be only having this and that according to the balanced equation. We'll look at that, what we mean by that. Remember, now your stoichiometry comes in. Oh, this is in the wrong place. Now your stoichiometry comes in. These steps are going to come in now. Balanced equation, converting everything into the number of moles and everything else that we've discussed, except for this time around, we won't be having a limiting reagent because the acid is completely neutralized. You have reached the end point of titration or the equivalency point of titration. At the equivalence point, all the acid has completely neutralized all the base. And we use an indicator to get that equivalency point. If we have time, I'll take you guys through that process. I'm not sure if we're gonna have time though. But I will definitely show you how to do that. So in this step, as we proceed, right, the balance equation for that reaction is this one. So there is your balanced equation. So step number 1 of stoichiometry is already taken care of. Balanced equation. The diagrams below show the period reading before the titration commenced and at the end point. So I have to read this. How do I read this? In liquid yakho in a burette, it curves like that. You read the bottom, the meniscus, the bottom of the meniscus. This curvature of a liquid in a small glass tube is called a meniscus. Meniscus. It's the curvature of that liquid in the small glass tube. We call it meniscus. Now they go on to say, use the burette reading to calculate the concentration of the sodium hydroxide solution. So how do I do that in question 3,4,1? I think I need a new page. They want me to calculate the concentration of, so look at what has happened. What is the volume of the sodium hydroxide? I need to look at my initial volume and the final volume. This is your initial volume. This is your final volume. So the volume that is used will be equals to final volume minus initial volume. This is the volume of the sodium hydroxide. Remember, this is the level of sodium hydroxide. So this is the volume of your sodium hydroxide that we have used. Read this. This is 2,2,4,6,8. Initial volume is 2,8 cubic centimeters, by the way, not decimeters. Cubic centimeters. Final volume, what about the final volume? 3,82, 38,2, 38,4, 38,6, 38,8. This is 38. Final volume is 38,4,8. So when I'm looking for the volume of sodium hydroxide, it will be 38,8 minus 2,8, which gives me 36 cubic centimeters. But I know that this needs to be converted. So I'm going to divide that by 1,000 so that it gives me 0,036 cubic decimeters. This is a volume. However, I know from the previous work that I've done, no, I don't know. I'm using of the acid, I'm only using 25 cubic centimeters. Now I'm looking at the volume. This is the volume of sodium hydroxide, by the way. Now I'm looking at your oxalic acid. For your oxalic acid, the volume that they've said we have used in titration is only 25 cubic centimeters. You didn't use the entire thing that you have prepared. You are only drawing a sample out of what you have prepared. Again, this is in cubic centimeters. We need to divide by 1,000 so that it is converted into cubic decimeter. And the reason why is because 1 centimeter, actually no, 1 decimeter is equals to 10 centimeter. So if I make a cube of this, I've got 1 cubic decimeter is equals to 10 to the power of 3, which is 1,000 cubic centimeter. It is for that reason. This is where the division by 1,000 comes from. 1 cubic centimeter is equals to 1 over 1,000 cubic decimeters. Hence, whatever the number of cubic centimeters, we must divide it by 1,000 to make it cubic decimeter. It's a simple maths. It's not magic. It's not because we like. No, it's a mathematical manifestation. Hamburg chemistry. You also know the concentration here. The concentration they said is 0.20 moles per cubic decimeter. That's a concentration of your oxalic acid. So we said, after having collected the data, convert everything to the number of moles. When I've got the concentration, the formula to use, C is equals to N over V. But this will be the moles of oxalic acid, where the concentration is 0.20 and the volume is 0.025. So you're going to multiply both sides by 0.025. You're going to multiply both sides by 0.025. I don't know what answer you are going to get, but it looks like 5 times 10 to the power of what? 1, 2, 3 to the power of -3. Am I right? Or am I right? Ntanza. Is that correct? The number of moles of oxalic acid there, is that correct? Now, guys, please assist me. Otherwise, we shall proceed with this. I mean, I'm doing this in my head because I don't have a calculator, but I know it's correct. No way it's going to be wrong because this is 1, 2, 3. Definitely 25 multiplied by 0.2 is 5 times 10 to the definitely it's correct.
It's
I've
correct,
confirmed
sir.
it. I've confirmed it too. Right. We go to the balanced equation, Tandla. We are going to use the stoichiometric ratio because this thing neutralizes the other. It means that they are going to react at the required stoichiometric ratio, which according to the balanced equation, what was that? Plus 2 waters. COONA 2 plus 2 waters. Now I'm looking at this stoichiometric ratio. I'm going to link this to by their stoichiometric. I know there's a stoichiometric coefficient which is 1 there. You also should see. I see that 1 mole of oxalic acid will be neutralized by 2 moles of sodium hydroxide. That is from the balance equation. Now, I want to know how many moles of sodium hydroxide will be neutralized by 5 times 10 to the power of -3 moles of oxalic acid. And if you remember from your grade 8 doing ratios, x times 1 is x. 2 times that, it will be 0.01 moles. These are the moles of sodium hydroxide. These were the moles that we've calculated here of oxalic acid, COOH, close bracket 2. Now these are now them. So I know the ratio 1:2 is the same as the ratio 5 times 10 to the power of -3 is to 0.01. I know. But they didn't want me to calculate the moles. They wanted me to calculate what? 3,4,1. The concentration of sodium hydroxide in the solution. So I've got the number of moles, and then I know C is equals to N over V. At this point, ladies and gentlemen, we must be very, very careful about the volume. We know the volume of sodium hydroxide. We have it there. We've calculated the volume. We said it's 36 cubic centimeter, and we found 0,036. So we are perfectly fine. 0,01 divided by 0,036, I think. 0,036. What is the answer there? I don't know. You guys will have to help me with that one. I don't know what the answer will be. But I know that it will have a lot of sevens.
0,278, sir.
Yeah, a lot of sevens, ne?
Yes.
Yeah, I knew that it will have a lot of sevens because it's 5/18. 5/18 is the same as what? 25/90. Yeah, that is where the 7 comes from. All right, so this is what they wanted you to do. That is what they wanted you to do. So we first look at the volume of the sodium hydroxide. Where did we get it from? We got it from the readings on the burette. We read the initial volume. I had the level was this much, but after titration, that is a level. So how much was used? It's a difference between the final value and the initial value. This is how much I have used. Remember, it was somewhere up there at 2,8. It was somewhere up there. So this is all that was used. Volume that has been used, which is from 2,8 to 38,8. That is exactly 36 cubic centimeters. Hamba chemistry. Last question. Okay. Last question. We're about to wrap this up. I think I'm running late for. Okay, I'm almost done. Write down a balance equation that explains why the solution has a pH greater than 7 at the end point. So which formula can allow me to that? Angisho mabethi pH greater than 7. Basho ukuthi lento le, it's an alkaline salt. So how can I prove that the salt is alkaline? I have to do what? Hydrolysis of that salt. And the hydrolysis must produce what? Must produce the OH minus ion. So which salt am I looking at? It is this very same salt. This is a salt that is formed. And which ions constitute these ions? I don't know why they like to write it like that because it's somehow confusing. Sodium should start first. Should be sodium, then COO. Because sodium is a positive ion, and the COO with the 2 at the bottom and the 2 minus at the top, that is your ion that you are looking at. So you've got these 2 ions right there, ladies and gentlemen. So they want you to show that the hydrolysis, this is the ion that I'm talking about. This is the ion that I'm referring to, by the way. That is the ion that we need to take. Sodium ion, we know it comes from a strong base. It ionizes completely. So the Na plus H2O, there is no hydrolysis. But for this ion, which comes from the weak acid, definitely hydrolysis has to take place. So we are going to take that very same ion. And the equation that will guarantee us is when we take this into water, but you are going to need 2 waters because of the 2 there, 2 minus. You are going to need 2 waters there. This will then produce the 2 hydrogens will go there, and then we're now going to have, but they're not gonna go as 2. This is how they're gonna be 2. And then what are left with? Are you left with? You are left with 2 OH minus. Why 2 OH minuses? Because even the acid itself produced the 2 H3O plus. Therefore, I will need 2 OH minuses. That is why, that is how I know. And the production of the OH guarantees that this is an alkaline salt. Therefore, this salt is a basic or an alkaline salt. And you are done. You put your point down and you are done. Easy like that. Buza. Questions? Hey guys, we've went by 7 minutes beyond this time that we were supposed to have. I don't know if you guys are having any questions before I release you, but this is how you handle things. There are different types of questions that I want us to look at. There will be questions that will want you to calculate percentage impurity. We'll look at those questions. Unati, well, maths classes, we are hopeful that from next week we will have maths classes. This week, Mr. Magai, our maths coordinator, our maths specialist, is on leave. Normally, under normal circumstances, we have 1 hour, 30 minutes of physics from 6 to 7:30. Then from 7:30 to 9, you'll have your maths classes. But unfortunately, this week, Mr. Magai is on leave. So next week, you're only gonna be having maths to make up for the missed physical sciences classes. But we may have to squeeze. We'll see how. I want us to have continuation, maybe on Tuesday and Thursday next week. But Monday, Wednesday next week, it's purely maths for 2 hours. I can still 1 hour on Tuesday, another hour on Thursday, so that we have continuity with acids and bases. So not this week, Unati. We'll only have maths next week, Monday and Wednesday. Then after next week, that other week, we are back to our normal schedule of 6 to 7:30 physics, 7:30 to 9 maths, Mondays and Wednesday. So we're just a bit messy this week. Okay? Yes, that's it. So guys, I don't know if there are any questions, but I hope you don't have any. I'm hoping that you do not have any questions. Like we always do, I think you are all in the group. Ntlantla, I think we've added you to the group, the WhatsApp group, where we share the information. Asanda, I remember we've added you to the WhatsApp group on Monday. Unati and Asanda were added on the same day, I remember. Ntlantla, I think we've added you a long time ago. If not, please make it a point that you indicate to me. Then I'll send the link to add yourself to the WhatsApp group. So everything we've done will be on the WhatsApp group. By next week, guys, I'm hoping that this work will be posted in our YouTube channel. A link will be shared to you. If you want to revisit this entire lesson and Monday's lesson, you should be able by next week to access it. In fact, let me check here. I think Monday's lesson is ready for download. Let me just check. Yes, it's already there. So I can, let me just. Oh, no. I don't know, something happened. Recording couldn't be uploaded, it will expire. Hey, I don't know what is going on. I think it's a Monday. I hope it's a Monday session. And I'll fix that. Okay, guys, this is it. I'll fix it when I'm alone. Ah, there it is. Monday session. Says recording is ready. and is set to expire. View or change the expiration date here. Okay. Okay. All right, guys, we are done. We are done for the night. Thanks for tuning in. Let's meet again next week. But keep in mind, Monday and Wednesday next week, we're going to be having maths only. I'm going to try to squeeze myself in on Tuesday and Thursday so that we continue with acids and bases just for 1 hour or 1 hour, 30 minutes. We'll see, but I'm just going to steal 1 hour of your time on Tuesday and Thursday so that we wrap up acids and bases. Other than that, and then we shall be left with Doppler's effect. Doppler's effect, I believe in one lesson we can do it all. We just need 2 hours of Doppler's effect and you will never have a problem with it again. Thank you so much. Good night. Let's meet again next week on Monday. And yeah, on Monday. Good night, guys. Bye.
Bye, sir.
Enjoy your evening. Bye, guys. Bye. You can go now. You'll get the work on the WhatsApp group. Evening session. Acids and bases. Okay. We need to export PDF. Okay, 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 okay. SharePoint.